Welcome to Study Loop.
The problem is, suppose that a scientist has reason to believe that two quantities x and y are related linearly. That is, y is equal to mx plus b, at least approximately for some values of m and b. The scientist performs an experiment and collects data in the form of points x1, y1, x2, y2, xn, yn, and then plots these points. The points don't lie exactly on a straight line, so the scientist wants to find the constants m and b so that the line y is equal to mx plus b fits the points as well as possible. So look at this graph here. So if we let di is equal to yi minus mxi plus b be the vertical derivation of the point xi, yi from the line, the method of least squares determines m and b so as to minimize the sum di squared I from 1 to n. Show that according to this method, the line of best fit is obtained when m times the sum xi plus bn is equal to the sum of yi, and m times sum of xi squared plus b times sum of xi is equal to sum of xi yi I from 1 to n. Thus, the line is found by solving these two equations and the two unknowns m and b. So for this problem, first we write fm b is equal to sum of di I from 1 to n. So this is equal to sum I from 1 to n yi minus mxi plus b square. So then we need to find the minimal value of f. So first, partial f partial m is equal to sum I from 1 to n negative xi times 2 times yi minus mxi plus b. Partial f partial b is equal to sum I from 1 to n negative 1 times 2 times yi minus mxi plus b. If we let each of them be equal to 0, then from the first equation, we have sum I from 1 to n xi yi is equal to sum of I from 1 to n xi squared times m plus b times the sum I from 1 to n xi. From the second equation, we have sum of 1 from 1 to n yi is equal to sum of I from 1 to n xi times m plus b times n. So we have the line of best fit is obtained when these two equations hold.